We want to show that the function f of xy is equal to square root of xy is differentiable at 1 comma 4. So in order for it to be differentiable, the first derivative with respect to x and y has to be continuous. So let's first start off with a definition of a derivative. So for f of x, so the partial derivative of f with respect to x, that's the limit as h approaches 0 of f of x plus h comma y minus f of xy all over h. And then for the derivative with respect to y, it'll be the same thing except we'll have h in the y term. So it'll be f of x comma y plus h. So because we're looking at 1 comma 4, we have to replace all the x's here with 1. And then all the y's will be 4. Okay, so let's start off with x, with the derivative with respect to x first. So we'll have limit as h approaches 0. X we set as 1, so it's f of 1 plus h comma 4 minus f of 1 comma 4. All over h. So I'm going to plug in f of 1 plus h comma 4 into the square root. So that's going to be square root of 1 plus h times 4. And the 4 can come outside because the square root of 4 is 2. So it's really 2 times the square root of 1 plus h. And then if I plug in 1 for x and 4 for y, I get square root of 4, which is 2. And that's going to be all over h. Then we have the limit here. If I were to plug in h is 0, I would get 0 over 0. So I would use L'Hopital's rule. And for L'Hopital's rule, the derivative of the top is just 1 over the square root of 1 plus h. And then the derivative of the bottom here is 1. Derivative of negative 2 is 0. If I plug in h equals 0, I get 1. So we found that the derivative with respect to x at 1 comma 4 is 1. Okay. So that means it's the first derivative with respect to x is differentiable. So that is continuous, in other words. The derivative is continuous. Now let's do the same thing for y. We're going to replace x is 1, y is 4. So now we'll be plugging in 1 for x, 4 plus h for y. So really, it's going to be square root of 4 plus h left. And then square root f of 1, 4, that's just going to be 2. It's going to be all over h. Plug in h equals 0, I get 0 over 0. So at this point I use L'Hopital's rule. So I get 1 over 2 times the square root of 4 plus h. The derivative of negative 2 is 0. The derivative of h is 1. Plug in h equals 0. I get 1/4. Okay, so what this means is that the derivative of f with respect to y at the point 1 comma 4 is equal to 1/4. So we were able to find both the first derivatives using the limit definition. And so we say that f is differentiable at the point 1 comma 4.